Hey there, calculus fans. I'm an instructor at the University of Washington, been teaching for 20 years. In this video, I'm going to do a review of for Math 124, try to help students that are in this course. I'm kind of on a mission to just help our students more, help you realize that we have a bunch of teaching faculty that really desperately care about you doing well. And if you can put in the time, you can be successful in this course. I'm going to talk kind of quickly because I want to look through one of my old exams. And in order to do that, I have to kind of move swiftly. But I hope this just sort of pops the ideas in your head. This is the review sheet from when I last taught the course. And I'm going to work through one of my exams in a second. So, basically the first exam, you do have a collection of pre-calculus facts that have popped up in the homework. So anything that's popped up in the homework, I'd add that to my note sheet. And then you have this big topic of limits. And to me, there's really two situations. There's finite limits and limits at infinity. And I'll talk about that, and I have review material for that. We have foundations of derivatives. We have continuity and differentiability. And typically we have a question. Usually there's a page where you do this. Typically, I'm not going to tell you because I'm not your instructor. You need to ask them. Typically there's somewhere we ask about foundations. Usually there's something about continuity. And my exam has these things. Derivative rules. Do we know how they work? And then probably some sort of applied problem that has to do with tangents or circles. That's pretty much what Math 124 exams always look like. I do want to point you out, if you do a search for me and click on my 124 materials, I've taught here forever. I have tons of materials. I haven't polished this page because I've been doing a lot of stuff in the last couple years and this has not been updated in that time. But there's a bunch of things here. Limits are not hard. Students say limits are hard. They are not. And I hope to show you that in a second. You just need to know if it's a finite limit, you're going to plug it in. If you get 0 over 0, you're going to simplify. If you don't get 0 over 0, then it's kind of easy to do. If the denominator is 0 and the numerator is not, it's either positive infinity, negative infinity, or it does not exist. So to me, if I had a note sheet, I know that already, but if I didn't remember, it's like a couple things, and I have a clear strategy. I think there's a worry about this algebra piece, but we'll do some of those in a second. If it's an infinite limit, you have a different set of strategies, mostly because if you're doing an infinite limit, you would really like to write 1 over x or things like it. Part of the challenge is people forget these graphs, but I have a whole bunch of problems here. Like, this is something you could hammer out. You would just look at those. There's solutions. I have continuity problems here if you need practice with that, if that's what's bothering you. So your job when you're studying is to figure out where your issues are, and then you can go to my page here. Derivative foundations. All of this here is on the right. Tangent line problems. All right. Made this years ago. Never made any money off it. I'm not very smart when it comes to that. But I hope this is helpful. So it could help me if you say, if you like and subscribe, not because I'm getting anything for that. I don't. But because I think my channel can help people. And if you can advertise it, I can do goofier things on there. Okay, let's get back to it. I've already spent too much time. All right, so here we go. Let's look at an old exam. Oh, I forgot. Kelsey Plum's going to help us today. I just got this bobblehead the other day. Thank you, Kelsey, for being here. Okay, winter 2017. This is my exam archive. My exam archive. There's a department exam archive, and you should study your instructor's exams. But my exams all have really detailed solutions. Different instructors have different ways they do things. So everything I do in a moment will check against that. Because I don't want to make a video and have a typo in it and then everyone emails me and says, you're a jerk, Dr. Lovelace. That's going to happen anyways. Okay, so here we go. So we have a finite limit here. So sorry that it's fuzzy because it's a one-note print, but I think it's good enough. We'll go forward. Not high quality. So you can say, his videos aren't high quality. We should stop paying him $0 for them. Okay, a finite limit. Step 1 is I would plug it in. What happens when I plug it in? I'm going to get 9 minus 4 over 3 minus 3. I'm going to get 5 over 0. This is that case where the bottom is approaching 0 and the top is not. The moment you see that, you should be thinking infinity minus infinity, or dne. So it really simplifies our thinking here. Now, how much you need to show, you should talk to your instructor. I'm just giving you the quick rundown as I can do it in a short amount of time. But to me, then I'm just chasing what's happening. We're talking about numbers. This symbol means slightly less than 3. So I'm thinking of like 2.99. And I don't need to plug it in. It's a waste of time to plug it in. I just need to think about what the sign will be. So if I do 2.99 squared minus, the top's going to be positive. So what I see is this is going to be positive and this is going to be negative. The answer is negative infinity. It's that fast. Let's see what I did last time I taught it. I said negative infinity. And I wrote it in this way, but I'm like, Anyways, it is that fast. Don't let those scare you. Next one, another finite limit. You try to plug it in and you immediately get error. You can't say infinity minus infinity is 0. That's never okay. If I go for a run and my son goes for a run, well, he's too fast. Maybe that's a bad example. And I'm always 3 feet behind him for the rest of eternity. Then the distance he travels is infinite. The distance I travel is infinite. And infinity minus infinity is 3. I bet you didn't know that. The point of that is it can be anything. You can never conclude anything from the symbol infinity. Hopefully you've gotten that already. So the moment you realize this doesn't make sense, you need to combine it into one fraction. So that's what we're going to do. We're going to get a common denominator so that I can plug it in. Okay, so we're going to do limit. I did not expand. 1 plus 6t plus 9t squared all over t. 1 plus 3t squared. Now I need to simplify, so I have to distribute. Don't let algebra scare you. Just embrace it. It's not that bad. If all you have to do is a little bit of algebra and you get to solve an important problem, you might say, well, this is not an important problem. Okay, I get that. Minus 12t minus 18t squared all over t. 1 plus 3t. When do you stop this algebra mess? And I canceled this 2. That's going to come out here and here. You stop when you get to a point where you can get rid of the 0 issue, and we're at a point where we can do that. Sometimes I joke with students, which one of these t's cancels? That one or that one? It's got to be one of them. Truth is, it's both, because you can factor out a t from the top. And if this is your challenge, is this algebra, hopefully the homework has given you lots of practice. But there we go. Now you can plug in a 0. You get negative 12 over 1. It's negative 12. So your job right now is to figure out where you're stuck in that issue, but the thing you can control is the process. This one was 0 over 0. This one was a constant over 0. A constant. Something not 0 over 0. Okay, so then we have this one. This is an infinite limit, so you're going to fall into that strategy. The strategy here is to rewrite it in a weird way. Basically, the strategy is to look for the largest power. And because you've done the homework and looked at these, this is about as hard as it can get. What I see on top is a power 2 here. Now, there is a power 4 here, but it's under a square root. And so that's like a power 2. So what I'm going to do is this. So if you're just thinking simplify or conjugate or whatever, you missed the important piece of information here, which is this is an infinite limit. We approach it in a different way. And the way we approach it is what I just did. We are going to try to rewrite it in a way that we can do a long-run analysis. And it's much easier to do a long-run analysis if you write it this way. So then we're going to distribute. This is going to be the limit as x goes to infinity of 4 minus, and then we have this huge mess. And normally I tell students to do this all in one swoop, but I don't know. I need to say something about this. So we are going to need to simplify that. And the way we simplify that is just a little maneuver. We call this a 4. We call this a square root. And then we put all of that under the square root. And with practice, you can do that pretty quickly. And you've done it a few times in the homework. So again, don't let that get you. So it's going to be x to the 4th over x to the 4th, which is 1. It's going to be 2 over x to the 3rd. And this is a weird way to write this function, But since you've seen these questions, you know that's the strategy. What's going to happen over here? Well, I'm going to have, well, this is 1 over e to the x, and I'm going to have 1 over x squared. That's what's in that spot. And then I'm going to have 3 over x. That's in this spot. And then we're going to play this same game with 5x cubed and 16x to the fourth. I'm going to divide by x squared, which is the square root of this, x to the fourth. We're going to put it all under a square root. So we have minus the square root of 5 over x. So that's hard, but you would know that's coming if you were preparing. And you go, well, why is that better? It's way better if you're trying to see what happens in the long run. Because in the long run, this goes to 0, this goes to 0, this goes to 0, this goes to 0, that goes to 0. And you're just left with 4 minus the square root of 1 over negative the square root of 16. So you're left with 3 over negative 4. Done. So this is when you're studying, you step back and go, I'm not going to be scared by these. If it's a finite limit, I'm going to plug in the number. If it's 0 over 0, I have more to do. If it's not 0 over 0, I'm done. If it's an infinite limit, I'm going to rewrite it. If you need more practice with that, that's what this stuff is here on my page. Limit strategies. So now you can go back and be like, all right, that's what he's saying here. Okay, let's keep going. I'm taking too long. I know. Oh, looks like I had one more finite limit here. And I think I'll do these first couple pages of questions, and then I'll stop and make a video to do the other questions. So now we have another finite limit. You know the strategy. Plug it in. So we're going to plug this in to all these spots. When you plug in pi over 2, what sign? If you don't know that, you would put that on your note sheet. I have a trig review sheet here. Oh, that's an old one. I have a nicer, newer one now on my other pages. I need to update that. Anyways, but you should know sine is the y-coordinate. And so this is going to be 1 minus the square root of 1 over, when I plug in pi over 2, 0. And so that's an indeterminate case. 0 over 0. So now we have to engage our algebra muscles. So this is 0 over 0. We would like to write it in a way that we can cancel the 0 in the bottom. And that does not look obvious what to do, but you have a strategy here. And we actually did this as a homework question. So here we go. It's an indeterminate case. We'd like to do some algebra. I have no idea what to do. Is there any way I can rewrite this? And that's one of our special techniques. That's that conjugate technique. That's just a way to get rid of a square root, or to rearrange a square root. But you see, I didn't automatically do that. I first did the thought process. Sine squared of t plus cosine squared of t. All right. And the point of this is what happens. And what happens is you get sine squared, and you get that square root goes away, and there's a minus in between. This is the difference of squares. That's why there's no middle term. That's the whole idea of the conjugate. So we're going to get sine squared. And this requires, you've seen this, but you would have seen it in the homework. And then we're going to get sine squared of t plus 4 cosine squared of t all over 3 cosine of t. And we should have this in our mind that our goal is to simplify, to cancel this. And so we should start having a little picture of, has this been successful? And then right here I'm going to write mess because I'm being lazy. I allow my students to do that. Okay, that cancels with that, but you're still going to have this negative. But then this cancels with this. Hooray! So it's going to be, and now I think I can plug in pi over 2, because if you plug in pi over 2 here, you get 1 plus 1, you get 2. Oh man, that's nice. Maybe Dr. Lovis isn't such a huge jerk. 1 plus the square root of 1. And so it's negative 4 over 6, or negative 2/3. Let's see what I messed up. We'll pull up my exam solutions. How am I doing? Yay, we did it. Okay, so now that's the limit component. So now you've seen it. I had one that was kind of a little tough for algebra, maybe. But the more important is the strategy. You don't want to be wasting time. Okay. Derivatives. You need to know your derivatives really well. You're going to be doing derivatives the whole term. One thing here, I'm doing the same thing with my business math students, is I find for some reason this really bothers people. And the issue is that's really pretty, but it's not set up to do calculus. And so we always have this, when you're an algebra student, you like to write things in a pretty way. When you're a calculus student, you write things in an ugly way. Not in an ugly way. In a way that we can easily use our rules. So this is 5 halves. And surprisingly, over the years, I've realized that that's the confusion students have. They don't realize that 5 over 2 times 1 over x is the same as that. They have this challenge of separating coefficients, in my experience, and that really holds them back. And I'm always like, that's the reason someone's failing calculus, because they don't know about their fractions. So let's get over that challenge and just say something about this. Now, some of those things I did were not necessary, but you got to realize what a coefficient is. If that 5 is somehow getting in the exponent, you have a long way to go, but we can do it. Okay, so anyways, this is 5 over x, then we write x to the negative 1. Ooh, what's this going to be? 1, so it's 4 fifths x to the 3/4, and then we have this mess. And then you have 3 terms, and for each term, you go, does it follow the... I like to say that the coefficients and the sums come along for the ride. So that's what I mean by saying there's 3 terms. There's 3 completely separate jobs to do. Okay, first job, this is going to be negative 5 halves x to the negative 2. And you should see, did the power go down? Next one, I'm going to bring down a 3/4, but that's kind of nice because the 4's cancel. So this is going to be 3 fifths x to the negative 1/4. Did the power go down? 1, yes. And then here we go, I'm going to do a quotient rule. Denominator driven the numerator minus numerator. And you could do this in another way, but I'm going to do it this way. Denominator, the bottom has the denominator squared, minus numerator. And I tell students there's no reason to have any of that wrong, because you're just copying on the rule. And then you need the derivative of tangent. And we really do need to know these. Secant squared. And then the derivative of the denominator is 5x to the 4th. Done. What do we have here? Oh, I rewrote it in a pretty way. That matches. That matches. Does this match? Uh-oh. Does it match? Let's see. Why does that say 4x to the 5th? Did I miscopy? Yes. Is there a typo in my answer? Oh, man. Oh, the 4 was already there. I distributed the 4. There's no typo in my answer. I just distributed the 4. You could simplify and cancel. It's not required. Okay, one more. Let's the slope of the tangent line at pi. Ooh, there's a lot of stuff going on. Product rule. You can clump it however you want. Let's clump it this way. First times derivative of the second plus the derivative of the first times the second. Let's plug all these things in. First derivative of the second. Loveless law of the C's. If it starts with a C, the derivative is negative. So I'm going to write negative sine of t plus, and now I'm going to need to do the derivative of the first, which is going to require some work, times the second. The first is 5t e to the t. How are we going to do that? Product rule. Ooh, all right. So we're going to do first, that's this, times the derivative of the second, e to the t, plus the derivative of the first times the second. And the question is asking you to plug in pi, so that should be extremely fast to do. When you plug in pi to sine, this is just 0. When you plug in pi over here, this is negative 1. And the rest of this is just a terrible mess. 5 pi e to the pi plus 5 e to the pi times negative 1. If it was me, I would factor out the 5 e to the pi and write it this way because it's just slightly prettier. Yay! Okay, so I think I'll stop the video and then I'll continue in the exam just to break it up a little bit and give myself a chance to get a drink, but hopefully that's helping you.